So as you know, sampling is a very important process to estimate the values in the population. So we take sample and we have to make sure that the sample is good. Now there is a very popular sampling method. It is called simple random sampling. Simple random sampling is defined as a process where every element in the population has equal chance or equal probability of getting selected. For example, let's say we have a very small population, and this small population consists of only 5 elements. So we name them A, B, C, D, E. We can number them like 1, 2, 3, 4, 5. If we are interested in selecting 2 samples out of these 5 using simple random sampling process, so that can be done in so many different ways. Like one way is on 5 pieces of paper, you can write A, B, C, D, E separately and fold them and mix them and ask somebody else to pick 2 of those papers randomly. So that also will be simple random sampling. Many times we make use of random number tables, and one such random number table is given in your homework file. So if you look at this random number table, and if you go from left to right or right to left, top to bottom or bottom up, whichever way you go, these random numbers are proved to be random. So there's no pattern in the sequence of these numbers. In fact, there are statistical tests available which can test for randomness. So how to use this table is very simple. If we want a sample of say 5, and let's say you start from the first one. So the first number here is 6. Now we have a population with numbers only 1 to 5, so 6 is of no use to us. So we can ignore that and move to the next one, because there is no dearth of random numbers. You can always go to the next one. Next one is 8. Now 8 is also not part of our population because our population ends at 5. We cannot use this. Move to the next one. And then you have 5. So your first sample, E becomes your first sample. Now for the second one, after 5 immediately you have 4. That also is a valid number. We can use 4, which refers to item D. So because we have not used our thinking, we have not brought our experience in selecting these samples, and we have totally relied on some random number table which has nothing to do with us. So we are making sure that the process is fair and it's also random. We are giving equal chance to every item. If I make a list of all possible samples, it is going to look like this. You could get AB in your sample, AC, and then with B's, so BC and DE. DE and ED both are same. So now if you see all these possible outcomes, you have like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 of them. And the chance of getting any one particular sample is 1 by 10. So AB has 1/10 chance, AC has 1/10, and so on. So each sample has equal chance of getting selected, and that's why this process is called simple random sampling. Now because we were selecting 2 out of 5, so you can use that formula that we used in binomial or hypergeometric distribution. Like how many ways exist for getting 2 out of 5? So number of ways you can get 2 items out of 5. So this formula you know is 5C2, and this is 5 factorial divided by 2 factorial and 5 minus 2 factorial. If you solve this, you should get 10. We have a population of interest from which we draw a smaller sample. Related to population, there is something called population parameters. Mean is one of the population parameters, and it is represented by this symbol mu. Similarly, standard deviation is another population parameter, and this is denoted by sigma. Related to sample, you have something called, so mean we represent by x bar for the sample and small letter s for standard deviation. Although our aim is to get an idea about population parameter like mu or sigma, we get that understanding about those values only through a sample statistic like x bar or s. So x bar is called is point estimate of mu. It is called point estimate of mu because it's a single point. Similarly, S is a point estimate of population standard deviation sigma. Because there are so many different samples possible, for example, in the previous example, out of 10 possible, we just got one of them and it happened to be E and D. But we could have got AB also or AD also. So it's like, so from 10 numbers, if you pick two numbers, you can get maybe one or two and your average may be 1.5. Or you may get higher values like 9 and 10 just because of randomness. It is possible to get 9 or 10 also. So if you get 9 and 10, your average is 9.5, which is much higher than what you got earlier. So basically your average values can keep on changing depending on what sample you get. It is very rare that your average will be exactly same as the population value. There will be some difference most of the time. So if you take absolute difference between x bar and mu, it is called sampling error of mean. If the sample from the population which is taken does not represent the population, obviously sampling error is expected to be bigger. So for example, if you are predicting who will be the next US president and you take a sample of like 3,000 people, which is a good number, like large number. But if you ask 3,000 people living in only say Dartmouth and you do not have any sample from anywhere else in US, obviously your sample is not representative and the sampling error will be very, very large. But if you take a more representative sample, maybe your samples are spread out in all 50 states, then your sampling error is expected to be smaller. So sampling error is directly related to how the sample is taken. So if the sample is taken properly and it represents population in a proper way, so obviously your estimate will be more accurate. So let's look at problem number 1. So Fortune publishes business related data for 500 largest US corporations. Assume you want to take or select a simple random sample of 10 out of 500. The companies are numbered from 1, 2, 3 up to 500. And we want to take a sample of 10. Now use the last 3 digits in column 9 in the above table starting with 554. So you have 1, 2, 3, 4, 5, 6, 7, 8, 9. But 554 is more than 500, we cannot use it. We move to next one. 459, we can use that. 147 we can use. So 459, 147. So make sure that when you are using these random numbers, none of the numbers are repeating because you don't want to take same company in your sample 2 times or 3 times. So they should not repeat. After 147, you have 385 we can use, and then 689 we cannot use, 640 we cannot use, 113, 340. 113, 340 we can use, 756 we cannot use, and then 953 we cannot use, 401 we can use. So this way we get a sample of size 10 out of 500, and this sample is a simple random sample. Now in this problem, it was indicated that we should start at 554. But generally how you use this table is very simple. Maybe you can close your eyes and then you point somewhere and then you can start at that location. You don't have to start at any specific location. And that's why, unless the problem says that you start with the specific position, people can get different answers. So that's not a problem. There's no one single answer as long as you are using simple random sampling. So that process is important. So that will make sure that you are giving equal chance to all possible outcomes. So simple random sampling is one way. You can also use Excel functions R, A, and D. R, A, and D. So that function can be used for generating random numbers. You can also generate random numbers between. So R, A, and D between. Let's say in that example we wanted random numbers between 1 and 500. So I could have written 1 and 500. So for example, Excel gives me 234 as the first company, and then you can drag this to 10 places and you have 10 different random numbers. So we could have used. There are other sampling methods also. So one of them is called stratified random sampling. And let me make a population in which we are interested. So stratified random sampling means you stratify the data in different strata or different groups. So strata is a group. So let's say I stratify this into 1, 2, 3, 4, 5 groups. And suppose I'm interested in sample of size 25. Now how to stratify this into different groups? Obviously there has to be some criteria. So maybe in a given study you may use education as one of the criteria. So maybe the first one is students who have not done high school. Maybe second strata is students who have completed high school. Third one is those with undergrad degrees. Then you have master's degrees and then maybe PhD degrees. Or your classification depending on your study may be with respect to income. So different people in different income group. And then maybe randomly we can select 5 from each group. Situations where stratified random sampling could make more sense is basically if you're taking random sample from a big population and let's say your criteria or one of the variables in your study is education level. So it might happen just by chance that all your samples come from only 3 categories and 2 categories are totally ignored, or there is no data on 2 categories just out of randomness. Maybe you did not have anyone in your sample with maybe PhD or maybe students without a high school degree. So stratified random sampling ensures that your sample is more representative because you are making sure that no group is missed. Another sampling process is cluster sampling. So if you have this population, and suppose on some criteria we can classify this population into 5 different clusters like 1, 2, 3, 4, 5. Now the key difference between cluster and strata is that within the strata you have a lot of similarity, like everybody with a high school degree or everybody within the group with a PhD degree. So a lot of similarity. But in cluster, there's a lot of variation. Probably like a cluster could be different states. So people in say Massachusetts or people in California. So within the cluster, there's a lot of variability. And another difference is in stratified sampling, random sampling, after dividing it into different strata, we took a simple random sample from each group. Maybe in each group you have like hundreds and thousands of people, but you selected only few of them. But in cluster sampling, what we do is, let's say we are interested in 2 clusters. And suppose our clusters through a random process are 2 and 5. Now, once you select 2 and 5 as clusters belonging to your sample, then everything or every element in those 2 clusters should be included. So it will be 100% within the cluster. So that's the key difference. Like in the strata, we were not going for 100% only simple random sample. But once you choose a cluster, you have to include everyone. Systematic sampling, as the name indicates, is a systematic process. For example, if you want to know how the economy is doing and you want to ask or collect data from people in our university, so you may decide, okay, I'll take a systematic sample by getting data on every 10th person I meet. So you start walking in the university, and then every 10th person you meet becomes part of your sample. So it's systematic because you are going for every 10th. So if a truck comes to the plant or this foundry and this truck is full of sand, it is very difficult to get a simple random sample from the whole truck. It's very difficult to get inside the sand and take samples from each and every corner possible. So what people generally do is they go for convenience sampling. They take a sample from the top and take it to the lab, look at the properties of the sand, whether it is usable in that foundry or not. And if the quality is good, they will accept the entire truck inside or they will send it back. So convenience sampling obviously is not a statistical sampling, but given the practicality or economics of taking a simple random sample, it will be very expensive really to take a simple random sample from every corner. It will not be practical. So people go for convenience to save time. So sometimes people use their experience or technical knowledge or expertise, like in an interview, they ask few questions. So basically, that process is sampling because it's very difficult to judge or know about somebody on a 100% basis by asking few questions for 10-15 minutes. So it's a sampling, but based on that, they judge whether this candidate is worth selecting or not. Judgment sampling is also used by maybe in sports. So people who have good eye, they look at some kids playing and they can tell that this kid will do very well in future and select that kid in the team. In a nutshell, basically it says that under some conditions, every distribution tends to become a normal distribution. So we have covered normal distribution earlier, and I mentioned that it is one of the most important distributions in statistics. And central limit theorem basically says that under some conditions, every distribution becomes normal distribution. So let me give you one example. Let's say there is a variable x and it has some shape, maybe irregular shape. Another variable, maybe it has a rectangular shape. Another variable may be right skewed. Another variable may be bimodal. So whatever shape it might have, under some condition or the other, all these distributions tend to become a normal distribution. That condition under which they become normal distribution is very simple. If you take a sample size greater than or equal to 30, so in statistics, anything more than 30 is considered a large sample. So if you take a sample greater than or 30 and then create distribution of x bars. Now what is the distribution of x bar? So please note that the x-axis I have put here is x bar and not x, which means if I take, let's say, a sample of size 30 from the first distribution and calculate x bar, I may get, I'm just making up some numbers, maybe 25.3. From the same distribution, if I again take a sample of 30, maybe I may get slightly different number because there's no guarantee that every time I will get exactly same average because the sample elements might change. So this way you can get different x bar values from the same distribution if we repeat the process. And from these x bar values, if you create a distribution which I have created here, it will be a normal distribution. So the mean of this distribution will be equivalent to or close to the population mean. And standard deviation, now I am going to use sigma of x bar. So standard deviation when we are using x bars. So this is sigma divided by square root of n. So in this case, sigma of x bar is called standard error. So to differentiate this from the regular standard deviation, so sigma of x is called standard deviation, but sigma of x bar is called standard error. So that's the key difference, because x-axis is now x bar axis. If you look at this formula here for the standard error, what it says is n, or the sample size, is in the denominator. Now, because n is in the denominator, as sample size increases, your standard error will come down. Your sigma of x bar reduces. So sigma of x bar reduces means the distribution becomes narrower, and basically our estimates become more and more accurate. In a large university, average age of all students is 24, standard deviation 9, and random sample of 36 is selected. Determine the standard error of the mean. So what is the probability that the sample mean will be larger than 19.5? Now, compared to calculations that we did for normal distribution earlier, please note that here it says sample mean. What is the probability that the sample mean? They are not saying what is the probability that the student age will be more than a given number. So they are not saying student age. If it was student age, then our x-axis would have been x-axis. Because the question is in terms of sample mean, our x-axis is x bar axis. So if you make a picture of this to do the calculation, so this is where you have to be slightly careful, otherwise it is a regular normal distribution problem. So once you make a picture and you know that problem says average is 24 and x bar, this is x bar and not x. So because this is x bar, then we have to use sigma of x bar here, which is sigma over square root of n, and this is 1.5. And the question is, what is the chance that it will be more than 19.5? 19.5 is somewhere here, and more than that means this area. Now once you look at this, you can see that this is a regular normal distribution problem. So if you want to solve this, you should do, because the area is on the right, you should do 1 minus and true. It is always true for normal distribution. So this will give you. So you can see this is done using normal distribution. The only key thing is you have to use sigma of x bar, because x-axis is x bar and not x. A bank has kept records of checking balances of customers and determined that average daily balance is $300 with standard deviation of 48, and they have taken a sample of 144. What is the probability that the sample mean? Again, you can notice that they are asking about sample mean and not individual x values. They are asking a question in terms of x bar. So you have to plot x bar axis first. Now another question from the homework, but this time it is about proportions. Although we have seen earlier in earlier chapters that if you have proportions, generally it is binomial distribution. But with larger sample size, that also can be approximated using normal distribution. So I'm going to make a picture here. So this is for average proportion, where you have p bar and sigma of p bar. A standard error of proportions is given by p bar 1 minus p bar divided by n. So a new soft drink is being market tested. It is estimated that 60% of consumers will like the new drink. So 60% means proportion will be 0.6. So a sample of 96, which is obviously more than 30. So because it is more than 30, we can make use of central limit theorem and approximate this data with the normal distribution. So determine the standard error, and then what is the probability that more than 70.4% of consumers will indicate they like the drink.